Hey everybody, welcome back to another episode of Rehash, a Web3 podcast. I'm your host, Diana Chen, and today we're speaking with Rene Lubov, software engineer at Celestia, about data availability, or DA for short. Rene is one of the founding engineers at Celestia and breaks down for us everything we need to know about DA and how it's implemented at Celestia. We also talk about modularity in blockchains, light nodes, and other technical concepts that you may have heard of before, but maybe don't have a clear understanding of just yet. Lucky for us, Rene does a great job of explaining all of these concepts very clearly. On a more personal level, Rene also shares about her background, how she taught herself how to code, what protocol engineering is and how it's different from app development or smart contract coding that you probably first think of when you think of devs in the space, what it was like being a founding engineer at Celestia, and her experience as a woman in crypto, having joined way back in the early days. This is definitely overall a more technical episode than most Rehash episodes, but I think it's a great one for everyone to listen to because I think it's useful even for non-technical people to have a basic understanding of how DA actually works. Rene was nominated for Rehash by Tina and voted onto the podcast by Tina, Jimmy Chain, Hudson Jameson, Queen Wartooth, and David Phelps. So without further ado, here's my conversation with Rene. Rene Lubov, welcome to Rehash. I'm so excited to chat with you, and I have to admit I'm a little bit nervous because I don't do these technical episodes very much. We don't have a lot of devs on the podcast, so I feel pretty rusty with just my knowledge of everything, and you're gonna have to bear with me and just keep it as basic. Keep an Eli 5 mindset throughout this whole thing if you can.
Yeah, it's fine. I mean, this is my first podcast anyway, so I'm not really well equipped to do it. So it's our kind of our first on both sides. So I think
amazing.
It'll be interesting. Yeah.
Amazing. Well, thank you for choosing Rehash, or thank you, Tina, for choosing Rene for Rehash for her first podcast appearance ever. Shout out, Tina. So I want to talk to you today all about data availability, and we've had a couple of guests on in the past on Rehash talk about data availability, but I want to do a really deep dive. I think in the past episodes, we've kind of just mentioned it in passing. We had 13-year-old VC from Eigenlayer on. We had Jimmy Chain from Catalyst on to talk about modular blockchains and DA and things like that. But I want to really just talk everything about data availability. My goal is that all our listeners understand everything, maybe not everything, but have a pretty solid understanding of what DA is by the end of this episode.
Okay. I mean, I can only talk about DA from the perspective of Celestia and how we implement it, because I'm not aware of the implementation details of other protocols. But yeah, I'm happy to give as much information as I possibly can. I honestly, it's funny because people make DA into this big, sexy term, and that's kind of difficult to approach. But really, it's a simple concept at the end of the day. It's just everything else in crypto is just named badly. Everything seems scary when it's named badly, and the name is not self-explanatory. So yeah, we can get to it.
So my super basic understanding of DA and what it is that it gives us a way to store data on chain in shorter increments of time, which allows for more space to store data, which allows for prices to be cheaper. It's my extremely basic understand. Tell me how wrong I am.
I don't really understand that.
Okay. You go then. You explain it. Let's just start with the basics. What basic from a very high level, what is data availability?
Okay, so DA is just, I'm going to call it DA because it's impossible to say data availability. It's kind of a misnomer. We've talked about it a lot. People have tweeted about how DA is a bad term. We should have called it data publishing instead. It's not it's not really a storage layer. Everybody thinks it's a storage layer where you can just store your data and then you can be able to fetch it whenever you want. That's IPFS. That's a different kind of protocol entirely. It has nothing to do with storage. Storage is involved, right? Storage is involved in every blockchain, but it's not that's not the crux of what DA is. DA, or we can call it data publishing, is just the ability to verify that some arbitrary data that you've posted to that chain has been included in a block and has been included in its entirety. It's really basic. It's just okay, I've published a message. Doesn't matter what's in there. It's some random bytes. Could be a string. Could be my name. Doesn't matter. I want to make sure that like RENE is published in that block and is like included it in its entirety. There's no like E missing. That's it.
Okay. So why is it such this novel thing? Hasn't data publishing always been a thing as long as blockchain has been around? The data needs to be published and verified. So what is all this talk lately about like DA and how it's like changing everything and making everything better?
The reason why it's like super sexy, right, is because you have, okay, so first of all, like DA has been around for a long time, like well before people started talking about it. It's been around since like the Lazy Ledger paper came out, which is what Celestia is built off of. Or like it's Lazy Ledger is the paper of Celestia, and Lazy Ledger was the name of the company before it became Celestia. Okay, so your original question was like, why is it sexy? Okay, so it's sexy because Lazy Ledger, like the concept of Lazy Ledger and the concept of data availability that was like talked about in that paper, is an answer to like the question of scalability in blockchains. And if we're going to like move into a roll-up centric future, like how are we going to allow participants in a network to be able to transact at like a high frequency without having every single participant in the network having to process every single transaction that is occurring in that system? And so the answer to that is rollups, right? So you have like independent, you could have like, there's so many different flavors of rollups. And I don't want to go into it.
Optimistic, ZK, those are like the more well-known ones, I would say.
Yeah, but then even like rollups that sit on top of a settlement layer, whether it's like a base rollup or like a sovereign after, like there's so many different ways that you can like build a system that posts data somewhere else to like some random data availability layer. Data availability itself was a response to like, okay, how do we scale blockchains? And the idea here is that like you can do that by, if like you don't need to have a system where every single node in the network has to process every transaction. You can have like minimal amount of nodes. So you can even have one node, which is called a centralized sequencer, that posts every transaction that's happening in that, like, I guess in the rollup itself onto Celestia. And then the participants of that rollup can cross-reference what it's posted, what it's saying that it's processing, like what transactions it's saying that it's processing with what it has actually posted on Celestia. The problem that it's solving there is that, like, say I'm a node, I'm that centralized sequencer, right? We can just call it like a main, it's just a node. It's just like it's a computer. It's a computer that is processing however many transactions. And you and I are participants in this rollup that this node, that the centralized server is processing, right? That centralized server could feed me information saying like, hey, I processed these transactions, this transaction set A. And I'll be like, oh, thanks. Okay, that's valid. That looks valid to me. And it could feed you a totally different version of the truth and be like, hey, I actually processed for this type that I told Rene I processed these transactions for. I actually processed these transactions. So it's feeding you a different but valid, I guess, state of what the chain is. And so the way to get around that is like you and I, and like, let's say you and I can talk to each other, right? But like if there's many other nodes in the network, we can't all cross-reference what this node is feeding us, especially not at the frequency at which it's probably posting messages or that it's producing blocks, right? So the best way for that, for us to be able to know that we are both seeing the same version of the truth is for us to go and look at like a pin board, right? Or like, what are they called? Like in high school, you had these like boards where you could post stuff like, oh, come to my
message board.
Message board. Yeah. Like a message board. Like come to my math club or whatever. It's literally the same thing. It's posted there. You and I know where to look. You and I know that if we look at this pin board, that I know what I'm seeing there is the same thing that you're going to be seeing. And that node and everybody else in the entire network. So that's kind of that's it.
So that's data publishing. That's
data publishing.
That's data publishing. Okay. So how does this like centralized message board then increase or help with scalability? That's kind of the thing that everyone's hyped about with DA is that it increases scalability and therefore reduces cost for the end user, right?
So we have a system, like there's many reasons. We as like users of this random rollup that I don't know what it's called, we don't have to process any transactions that are happening on some random other rollup somewhere out there and God knows what, doing God knows what. We just care about what we're doing. Like we care about two things. We care about what we're doing, that like everything that our node is feeding us is true. And we also care that the system that we're looking at, that message board is like has integrity. Those are the only two things we care about. We don't care about anything else that's happening on any other rollup. So we don't have to process any information that's happening anywhere else. We care about our information only, and we care about the integrity of like the place where we get that information. And so it really reduces the things that you have to verify, like the things that you have to do to verify like the integrity of like your own, like the system that you're interacting with. Does that make sense?
Yes. Yeah. To take a step back, when we say that somebody like a protocol or a product is using data publishing, is it even possible to have a blockchain or a protocol or a product that doesn't implement data publishing or DA?
I mean, you can have things like, you can have like blockchains. Okay, so DA is different from how blockchains currently operate because DA makes it's a different way to verify the actions that you're doing are correct and that the system that you're interacting with, it has integrity, right? But like other blockchains do that by processing every single transaction. So every participant in the node, if they want to have like the fullest security guarantees of like the system that they're interacting with has integrity, they have to process every transaction and arrive at the same conclusion as every other node. It's very like resource intensive to do. And so you've reduced like the amount of work that a participant of the network needs to do in order to be able to trust that system.
Gotcha. So is that something
that reduces the jobs?
Yeah. Gotcha. It like consolidates things, makes things more efficient. Is that something that needs to be done at the blockchain level, or is that something that like app builders integrate DA into their apps? Like which level? It's at the blockchain level, right?
It depends. Like if you want to have something called an app chain, like where you build your own application, you can absolutely just use Celestia directly. And you can have like a single like centralized sequencer that uses Celestia. And every participant in your app chain is able to verify that your sequencer is actually posting what it's saying it's posting and feeding the same information to everybody around. So like you can be an app developer and you can make an app chain. It's just maybe a little bit more work than, well, actually, I don't even know. I've never built an app before. And so I've always been on the protocol level. I've never like written a smart contract. But I can imagine that there's probably like difficulties in terms of like creating a smart contract type protocol, an application that uses smart contract versus an application that uses an app chain. They're just two different sets of problems. I'm not saying that it's easy to onboard. Of course, it's still like fairly early, but you can use Celestia directly if you're building an app for sure. You can also use Celestia if you have like an existing chain and you want to transition to like either you have an existing chain and you feel like you don't need to have the full validator set that you have. For example, like in like Cosmo or tournament based chains, we'll usually have like a large validator set. You don't necessarily need to do that if you use Celestia. So you can transition to using Celestia as a blockchain.
Okay. And when you say app chain, you're talking about like app builders that essentially create their own, like a new blockchain to build their app on top of.
Yeah.
For their app,
it's like
specifically.
Yeah, exactly. Their app, like this app is the only like application that is on that chain. Yeah.
Gotcha. Okay. And people would want to do that because it just gives them more control over the features, the customizability of whatever app they're trying to build.
Yeah. There's a lot of like, okay, so this is not my area of like expertise. There's a lot of like, it's very theoretical as well. So like there's better people to talk to than me about like whether you should be building like a base rollup or ZK rollup. I don't know, like all these different applications that you could, or there's many different flavors of like how you can build the thing that you want to build. And I'm sure that there's like trade-offs between all of them. But yeah, like if you want to have like extreme customizability, extreme control and like sovereignty over the way that you build your application, you could absolutely do that and then use Celestia as your DA layer.
Yeah. So
it's very well suited for that. Yeah.
So Celestia, is that just essentially like a developer toolkit that like, is it similar to like an SDK that developers can just plug and play into what they're building?
It's not an SDK. We have a team that's building, there's a team in the ecosystem that's building an SDK to make it easy to create these kinds of app chains on Celestia. It's called a role kit. But Celestia itself is not an SDK. Celestia is you can use it as you would any other, I guess, blockchain. It has an API that you interact with, a very minimal API. We're still working on making it better and working on making it a little bit more standardized, a little bit like more intuitive to use. Obviously, there's still like we kind of build this thing together with the users that are building on top of us. So it's an iterative process, but you would interact with it via an API. that is available on like the Celestia data availability node, which is a thing that I work on.
Okay, gotcha. And any developer can come in and use that API just like they would use any other API.
Yeah.
So, I mean, it sounds really convenient. It sounds really cool as saying this as a non-dev, of course. So with DA and everything it enables, are there any challenges that we face with DA or like any limitations?
Yeah, I mean, there's tons. We don't solve every problem. So it's not perfect because like at a high level, and this is the thing that I see the most people, I guess, having qualms with or having like difficulties with is the fact that like if you are an app chain, if you are a sovereign chain, and there's many other sovereign chains out there, it becomes difficult to understand what is happening on those other chains. It becomes difficult to interact with those other chains, but there are many solutions for that. So there are like, this is one of the biggest things that is being looked at by people on the ecosystem of Celestia right now is like, yeah, how do we get like cross-chain interaction between these app chains?
Yeah.
Yeah. And the answer to that is like IBC, for example.
What's IBC?
What was it? Like inter-blockchain. I don't know the actual acronym, but it's like a message passing protocol between chains.
Okay. Gotcha. So a lot of people, I think, associate Celestia with modular blockchains. Can you explain what a modular blockchain is versus the alternatives?
Modularity is like, it's like Celestia's thing. We talk about it a lot. We talk about like modular in terms of like customizable, in terms of like you get to choose all the different components of your blockchain such a way that like you have you're not beholden to anybody else, and you're not beholden to like the decisions of like some other random protocol that's out there that's, you know, kind of locking you into a certain kind of behavior. That's basically it. It's not really like super sexy, I guess, when you actually, it's nice because it gives developers a lot of options, and like doing that is very good because it allows developers to like the freedom to design how they want to. It also lowers barriers, I think, of entry. It can, for example, if you do it right. But yeah, that's really all that it's about.
Okay. And then how does that relate to DA, or are they just totally separate things?
Yeah, I would say that they're like DA, and the way that we've implemented Celestia enables this modular, like the ability to like customize your own chain. So, which is what we call modularity. The way that we've implemented Celestia DA, I guess, which is we've separated execution from consensus. And so we call that modular. And then also the ability to like, I don't know, you have your own, if you build like an app chain or like sovereign chain, for example, you want to build it with certain kinds of components, or it has its own consensus mechanism. Like you could do that. You can have like, I don't know, a set of like 4 validators. They can do whatever you want it to. Like Celestia basically enables that. It's not necessarily like inherent to the DA as a, I guess, concept.
Can you break that down further, how Celestia implements DA by breaking down execution, like separating execution from consensus? Can you just explain that more?
Yeah, so we like Celestia does not perform any kind of execution over the transactions that happen inside of the rollups. So whatever the rollups are posting is taken as like a arbitrary, like it's just arbitrary bytes. We do not look into what those bytes actually are. We do not have any concept of like what a rollup blocks look like what the format of a rollup block is. We have no concept of the rollups like state machine. We don't understand anything that's happening on top of the rollup. What we do is we take that message and we include it in a block if it's paid for, and then make that block. That's it. So we do not perform execution over the transactions that occur on a rollup.
So Celestia just handles the consensus layer. Doesn't touch the execution layer.
The ordering of those messages in the DA layer. Yeah.
Can you talk more about the consensus mechanism, or is it pretty much just like that simple?
It's just Tendermint.
Okay.
Like we use Tendermint. We've made some modifications to Tendermint, but yeah, it's just Tendermint.
Okay, gotcha.
For the consensus mechanism of Celestia, of the Celestia chain.
So Celestia, just to conceptualize this more, when you say the Celestia chain, it's not an L2. How would you categorize that?
So, okay, technically Celestia could be an L2 on top of Celestia. Celestia itself is just like a chain of blocks that contain random bytes. And technically, Celestia transactions also post their transactions to Celestia, and they're contained in that block. So technically, Celestia is a roll-up on top of Celestia in terms of like the data availability layer. What ends up happening is that Celestia needs to have a chain, right? It has its own like format for payments. You can transfer money back and forth on Celestia using TF. And you do other things, right? Like you can stake on Celestia. So there's activity that happens on the Celestia chain, and Celestia chain produces blocks. And the Celestia chain just also happens to like have a transaction type that's like the ability to post these arbitrary messages to Celestia as well. So the contents of like a Celestia block when it comes to the DA layer is just like arbitrary shares, whether they're from Celestia, whether they're from the rollup that we talked about, or some like other random rollup, Astria, like any other rollup that is built on top of Celestia. All of those transactions, or those messages, we could call them, are posted in the same block, and they're part of the same sampling process that light nodes perform. And so like the Celestia chain itself is just a way to order, like it's a way to process what is happening on the Celestia like DA network, like people paying to post their blobs, people like transferring, wallets transferring money from back and forth, and then other activities that are happening in Celestia.
And is Celestia compatible with like all other L1 and L2 chains? Like, is it compatible with any rollup? Is it compatible with Ethereum, with Solana, with any other chains?
By compatible, if you mean like directly pluggable, like no, because they don't have the interface to be able to do that. But if they built the interface to be able to do that, then yes, like it definitely you can plug into Celestia and post your blocks or blobs or whatever you want to post there. So it is like, it's very simple to use if you want to use Celestia as a DA layer. There's like there will be a minimal interface that you need to comply with, and then you'll be able to post just like any other rollup.
Okay, so any dev building on just about any chain can
turn their chain into a Celestia, like can use Celestia for DA. Yeah.
Okay. Gotcha.
But like not out of the box, they'd have to do something.
Long term, what is in Celestia's future from what you know?
A lot of things. There's near-term future, there's long-term future. We get to the long term, we want to increase the number of light nodes that are on the network so that we can increase the block size. What is
a light node? Sorry to cut you off. What is a light node? Because you've said that a couple of times.
Yeah, the light node is like the baby of the Celestia, I guess, implementation. It's very cool. My colleague and I, back in Istanbul, like during DevConnect, we did a presentation about like what is a light node relative to like everybody knows what a light client is, kind of to a certain extent, right? And there's like a fairly common understanding about what light clients do, but light node kind of turns it on its head because light nodes are just like lightweight, like very lightweight nodes, essentially. So you can access the network with a very high security guarantee. The thing that Celestia Light Node does, that's different from like other light client implementations, is that it performs something called data availability sampling, which everybody likes to talk about. DOS. Essentially, DOSing is just a way to like very lightweight check the integrity of the Celestia network without having to download every single Celestia transaction, process it, and make sure that it's included, or download the entire Celestia block.
So is it like you just sample certain blocks
you sample
and make sure
random
that
points from the block,
and you assume if there's like integrity there, that like there's integrity overall?
Yeah, so it's confirmed with a like probability that there's enough light nodes on the network that are sampling randomly from this block that the sufficient amount of the block is sampled such that everybody can confirm that the block is actually there.
Gotcha. Okay.
Yeah.
Okay. Sorry to cut you off earlier, but
no, it's okay.
Continue.
Yeah. By the way, this is like, I don't often explain these concepts, not completely Celestia like implementation related. So it's a bit of a challenge for me to like explain it from like a higher level. So I appreciate you like stopping me and asking me questions along the way, because otherwise I'd get like maybe 2 in the week. But yeah, so light nodes can do data availability sampling. They can also post and retrieve blobs from the network. So like you and I, as users of this like rollup that we were talking about before, we could check the node or like our centralized sequencer to make sure that it's actually posting what it's saying it's posting by going and retrieving the blob from Celestia network. And then also simultaneously, we want to make sure that Celestia network is valid as well. So our nodes like in the background is also performing data availability sampling on every single block in the Celestia network.
Gotcha.
So it's doing 2 things. It's helping you retrieve your blob. So it's helping you like cross-check your centralized sequencer. And it's also making sure that the place where you're cross-checking the centralized sequencer is also like high integrity.
Gotcha. So it's double security layer, essentially.
Well, it's like giving you those security guarantees, yeah.
Yeah. Is that more security guarantees than you typically get with like Ethereum, for example? or like another blockchain without DA?
Well, if you're a full node on another network, no, because you'd be downloading every single transaction and processing it. But it is more security guarantees than you would get with like your average light client implementation. Yes.
Gotcha.
This light node that I'm talking about.
The light node. Yeah. Cool. Any other like long-term, was that long-term or near-term that you started talking about?
No, this was long-term. Like long-term. I don't know how many million light nodes on the network, 1 gigabyte blocks. We talk about like massive throughput. That's something that we're working towards. Near term, there's like smaller things that we can do to make our system a little bit more like optimized for like immediate use. But there's many things that we're working on simultaneously. We're also like cleaning up tech debt that's related to us shipping the DA layer as fast as we possibly can. We shipped it in 2 years. I think it was 2 years since we started the initial implementation to actually like shipping the thing. It was, we started building it in August of 2021. Like we had the initial design in August 2021 and we launched in October 20, what year is it right now? It's
2024.
October 2023. Yeah. So it's like a 2-year turnaround. It's like pretty good.
Oh, wow. Okay. So Celestia has only been live for under a year.
Yeah. To get to the point where we could launch our network very quickly, we had to make a lot of decisions to use existing tech that is out there with like, and not rebuilding the wheel like every other protocol does. Many other protocols love to just sit and like bike shed about like very, not necessarily not important, but like smaller details in the network instead of just using like existing libraries that are out there. And we made a lot of decisions to use existing libraries that were out there. Tendermit's not a library, but like we decided to use Tendermit for the consensus. We made a lot of decisions that accrued some tech debt along the way that we need to resolve as we go along, like chip away at. And so we're working on that as well. We've like with any other implementation of anything, we are trying to optimize the way that we store and distribute data across the network just to make it as like fast and as fast as possible, and also as like least resource intensive as possible. So that's something that we're working on as well. We're working on trying to make header syncing very fast so that light nodes can be even lighter, can get on the network as quickly as possible, meaning like they can come up on the network and then they can very quickly download the chain and like verify that the chain that they're looking at is the correct chain and that they're not being fed bullshit. And that makes it easier for wallets to have light nodes connected to them, so that they can actually see the state of the chain very quickly and very trustlessly instead of having to like connect to some like RPC endpoint that's being provided by God knows who.
Gotcha. That is a lot. It's crazy to me that you guys have only been around for under a year because, I mean, granted, I have like no concept of time, but it feels like Celestia has been around for way longer than a year, which is why I was surprised.
We've been talking about it for a very long time. We've had test nets as well, but now we have a mainnet and we have real users and adoption, and so it's becoming like bigger and bigger, and the ecosystem is growing larger and more colorful. But we've been talking about it for a long time. Like Lazy Ledger Paper was out in like 2018, right? And then it only really started to be built out in 2021.
Yeah. So from a more personal level, you were one of the founding engineers, I believe, at Celestia. What was that experience? Was this your first time being a founding engineer?
Yeah, it was. Yeah.
How was that experience compared to your previous experiences, just like as an engineer joining an existing team?
It was awesome. Like it was so much fun. It was unbelievably fun to get to build something so interesting and so like technically complex with like a group of people that are just fantastic humans. Like I love everyone on my team. I really I say that genuinely. I love everybody on my team, and everybody on the founding team was like so much fun to work with. Very different thinkers. The tech leadership around it was like everybody was just super knowledgeable, very like intellectually honest. The best part about this was that nobody on the team really had an ego. Like we could all very honestly discuss ideas without anything being personal. And the initial design and like the initial when we met up to spec out what Celestia would look like as the initial implementation, it took us a long time. It was very exhausting. We would get heated into like heated debates about whether we do this or that or this or that, but it was still so much fun and very engaging. And I loved initially I was working just with one other person. His handle on Twitter is Wonderkin. His name is Gleb. We were working together on the Celestia node implementation, which is the DA node. And it was so much fun to write this thing with him. And like, I always am kind of nostalgic to like the good old days when it was just like us writing code and not having to deal with anything else. So we could just be like in the zone for like days at a time, come up, review each other's PRs, go back in the zone. Yeah, it was a lot of fun. It like, I don't know, people talk about it being like super stressful, but that like, it's very stressful for founders, right? But like founding engineer is different because you basically have this like, most of the time you have a clean slate. Like Evan didn't really get to have a clean slate because he had to work with Tenderman, but like Lev and I got to have a clean slate where we got to write our own node from scratch and make so many design decisions around it. And yeah, it feels, it's very fun. I think it's just a very, very fun experience. Yeah. It makes me very happy even thinking about it.
I can tell. I can imagine too that it would be a really positive experience for an engineer to be able to start something from scratch, because then you're not dealing with code that somebody else wrote that's like potentially wrong or just like messy or just like a different style than what you prefer. And now you got to decide how you wanted to write it, like what style you want. And now everybody else joining the team just has to deal with that and kind of adapt to your style. So that part has to be nice.
Yeah, it was super nice. We obviously like, we use a lot of code from other teams as well, I guess, like other libraries. So we do rely on other code. It's not all fresh. And we are still beholden to like decisions from other teams. And we also like, it's not like the DA network is totally separate from the consensus network. We had to inherit like certain types from the consensus network, and we are still locked into certain behaviors, behavioral patterns from the consensus network. So we're not like totally isolated, but we did get to have a lot of freedom with how we design the code base. And that was really lucky and nice.
That's awesome. For that. Yeah, for sure. That's super awesome. Can you also talk about how protocol engineering is different from like app engineering, like smart contracts? I think when most people think of devs in the space, they think like Solidity, smart contracts, like that's, what is this like protocol engineering? It sounds so like elusive and mysterious.
Yeah. Okay. So I've never been an app dev, so I don't even know how to speak to what it's like to be an app dev. And I've only heard things, but from what I understand, it's like I don't know, if you're a smart contract engineer, you probably will write way fewer lines of code than you would as like a protocol engineer, just by the nature of the language and by the nature of like the thing that you're actually doing, because you're implementing some like very small, or like it can be very complicated logic, but it's not as expansive as like having to write every single component from scratch. It's a very like scoped problem, I guess. Whereas with protocol engineering, you're essentially building a distributed system. It's very like intense. You have to build out several different components of this stack. You can start this node, or you can start this piece of software, and it has to run perpetually and interact with other pieces of software that are just independent and also running perpetually and also processing like transactions. So there's a lot more involved, I guess. There's a lot more surface area involved in protocol engineering. And that doesn't necessarily mean that it's harder, or like it's just different. Like you have a different set of problems that you're solving. Yeah. Protocol engineering is a lot of fun. There is still like a lot of problem space that can be researched and optimized. And like there's many engineers out there that are doing it.
Tell me if this is a good analogy, but the way that it kind of sounds to me is like a smart contract or an app dev is essentially like building a building. So you're like, I want to build a house, or you're like, I want to build like a mall in the city, or I want to build X, Y, and Z building. And it's scoped out, like you're just there to build this building that somebody asked you to build. Whereas a protocol engineering, it's more like you're trying to develop a city, like you're almost like a city planner, or like.
Yeah, you could talk about it from that perspective. You can also say like the protocol is the mall and like the app is the store inside the mall, or something like that. You could say it like that. Yeah, protocol is just like all the infrastructure that is underneath to allow that app to function.
Right. Yeah, because I mean, with like the whole city, it's like you have to consider not only the buildings, but the roads, all the subway, like all the other infrastructure involved as well. And that's like what I imagine like being a protocol engineering is, like connecting all of those dots as well.
Yeah, to a certain extent. Yeah. Yeah. I don't like there's obviously so many like nuances to it. And there's like there's differences in like the mode of work, even like how you would organize a team that's building protocol versus app dev. I'm not aware of like how app dev is organized, but like protocol engineering teams are usually like fairly large. Yeah. And then like their experience doesn't need to be like blockchain specific. That's another thing, is that it's nice when they do have blockchain specific, I guess, experience, but you can come from any kind of like most engineering backgrounds and be able to get into it fairly easily.
I want to jump over to some questions we had on Twitter, and we had a lot for you.
Yeah.
Some are more serious and some are more just for fun. While I get this pulled up, one question that Tina had for you, actually, who nominated you for the podcast, was, can you describe Berlin ETH culture and how it's different from other cities?
Oh, wow. Okay, yeah. So this was a long time ago that like Berlin ETH culture was a thing. And okay, I don't know, I feel like I'm going to get like shout on for things that I'm about to say, but
no one come after Rene. We like the spicy takes here. The safe space.
It's still like fairly alive. There's many like engineers, like Ethereum engineers that live here, that have been living here, that didn't like fuck off to Lisbon like many other people. But yeah, the ETH culture is still very live here. There's still ETH meetups. I would consider like the ETH culture here to be more like skewing towards the cypherpunk heavy like ethos of like crypto culture that was like pretty OG to at least when I joined or I started working in crypto. It's still very much alive here. There's many people that I like super highly respect that continue to keep it alive here. Like Franzi, for example, is one of them. Afri is one of them. Ligi, Felix from the Geth team is here. There's like many awesome developers. Like I can just keep like naming them off. Just very cool people that are like super high integrity, like committed to this vision for the most part, and like keep that spirit alive in Berlin. It's no longer like this like central focus point of crypto anymore. It used to be very like heavy Berlin centric when, you know, Parity was doing their events here and Parity had like the offices here. I mean, there's still a lot of Parity people here, but it kind of dispersed like all over the world, which I guess is a good thing, right? Because it's decentralizing. But then there's like micro like crypto cultures that have been popping up. But I would say like the ETH Berlin and like crypto Berlin cultures are like more heavy on like the cyberpunky side of things. I can't really speak as much to the Cosmos, like, because there's a lot of Cosmos in Berlin as well. And like, you know, they're integrated, but they're not really like super integrated. But yeah, that like, I would say that they still kind of, it's like a lockbox of like, I don't know, the feelings and the emotions that we had from back in the day.
Yeah, cool. I love that. That's very cool. Did you move to Berlin to start working in crypto, or did you get into crypto after moving to Berlin?
No, I didn't move to Berlin to work in crypto. I actually started working crypto well before I moved to Berlin. I ended up moving here just because I liked it. I had a lot of friends here at the time. And so I thought that like I lived in New York before. I didn't like New York. And I just really loved Berlin. I thought it was a very nice city, which it kind of is. More of a...
Yeah, I like Berlin a lot personally. I've never lived there, but I visited a few times and I love it every time I go.
It can be nice in the summer.
Yeah. Yeah. Sure. Another Berlin question. This one's from Jimmy Chain, 0x Jim. What's the best donor in Berlin?
Okay, 100% Hisier. No other like competition. Some people say Imran. I say not. It's Hisier.
What makes Hisier better?
I don't know. I think they put like, they have like, either they have like integrated lamb fat in the kebab itself, that like drips over the kebab like all day and like infuses in that meat. It's a banger. And they make their own bread and it's just super fresh. I like the guys that work there too.
Oh, I'm getting hungry.
Yeah,
I'm getting hungry.
Good. Very good.
Okay. Question from Hudson Jameson. What is the most challenging part of making a pivot to being a professional coder? Were you working as something else before?
Yeah, I wanted to go to law school.
No way. I started my career as a lawyer. Like I'm a lawyer by trade. So you made the right choice.
I think I did. Like back in the day, I was like talking to so many different lawyers, Nelson, and I like, they were like, don't do it. Don't go to law school. You're going to hate it. And I was like, oh. But I'm very glad that I chose not to. So yes, I did pivot. And I also just like, I don't know, I kind of was trying to like gaslight myself into like thinking that I found law interesting and like the legal stuff around crypto interesting, which I kind of did at the time, but like also I wasn't as interested in it as I was in like how the thing actually works. So I'm glad I did pivot. But the like, I don't know, there was, so yes, it was challenging, right? Like it's a totally different profession. You have to learn a lot of new things. And I was kind of like thrown into the depth of it just because I started working from like a very strange angle. I started working on like a distributed systems testing framework. But I'm really glad that I started there because it was like, it threw everything in my face very quickly. But it was like crazy challenging. I had no idea what I was doing. It's like learning another language and trying to speak to people in this like language when you're like, I don't know, 5 years old, like the level of a 5-year-old.
Wait, so you didn't go to school for computer science?
No.
Or anything?
No.
And then
no.
how did you learn to code?
I took a couple of like programming classes while I was in university because I finished my degree early, but I learned Go on the fly. Like I started writing unit tests for the code that was white block back in the day. And I just started writing unit tests and trying to understand how the code functioned through that. Yeah. It was brutal. Like it was a brutal onboarding experience. There was no like I didn't do the thing where like you do the coding boot camp and then you make the little game and now you know front end. And no, I went and I wrote unit tests for random functions in the white block code base.
That's super impressive. How long would you say that like what you would consider to be that like transition period?
I like sucked for a long time. Like I obviously like you can't learn that much stuff in that short of a period. But I think that I like within like a couple months, I started like grokking Go. And I had like, okay, by the way, I had the best mentors in the world. I had like access to the best, like some of the most talented engineers in this entire space. Zach Hole, Antoine Touré, Preston Van Loon. Who else mentored me? Like there were so many people that mentored me that like a lot of them were like former E2 devs or like still are E2 devs back in the day. And they were all just like helping me learn Go. Nate from White Block was helping me. Like it just, yeah, like they were all kind of rooting for me and explaining random concepts to me and meeting up with me and giving me their time. I owe like everything to these guys. Dean as well helped me a lot. He like helped me probably the most. I owe everything to these people. Like they helped me the most.
How were you able to secure such amazing mentors? Was it just the fact that you were so early in the space and you were like one of the few people that actually wanted to learn it? They were like, yes, like, let me help you.
Yeah, I guess so. I guess so. I think also like, I mean, I was young at the time and I was really like passionate. And I think that I'm just a like if there's one thing that I can say about myself is that I'm like honest and loyal. And I think that goes a long way. And I think these people just like took a chance on me and I knew them through like other friends and connections. And like at the time, Preston lived in New York and I lived in New York. So we meet up sometimes. And yeah, it was awesome. That it was like being early, just knowing these people through friends and other connections.
That's awesome. So related to Go, since you were just talking about that, WonderTan had a question for you. How does Go header solve liquidity fragmentation of the modular stack? And then, okay, it's a two-part. And then there's another question. How did it feel to be arrested by context police for the first time?
The first question is like a inside joke.
Okay.
The second question is also an inside joke. Like most of these questions are inside jokes, but
I was gonna say, like I told you before we started recording this, you're gonna have to explain the question before answering it because I didn't understand half of these questions.
Yeah. So the first question, it's a joke about how like one of the libraries that we built is going to solve the hardest problems, which it's not, but it's a small inside joke. The second one is context police. This one is very Go specific. Go has this concept of context. And you can pass around these contexts through different like function calls. And so you could do many things with these contexts. Sometimes people like abuse the context. And I've been arrested many times by the context police where like I forgot to set a deadline on a certain context or I never canceled the context, so there's a leaked context. But we, like, anytime we review a PR and we catch a context specific error, we put the little police emoji and the context police comes and arrests you for misusing context.
I'm so glad you explained that, because not in a million years would I have guessed that. Like, if you gave me 100 guesses, I would not have gotten to that. So I'm very glad you explained that. Let's see, we'll try to get through as many questions as we can. Marius Vander Weyden.
Yeah, Vander Weyden.
Hopefully, Vander Weyden. What lessons did you learn from being part of Geth, and what lessons would you take back to the Geth team?
This was probably the most like substantive question, I guess, that I saw, at least from the questions that were posted. Marius and I worked together on the Geth team briefly while I was there, and like the Geth team is like one of the most goated like engineering teams, period. They're a group of people that are like unbelievably high integrity, very like intellectually honest, extremely good, like loyal people, and just like great people, period. Like every single person on that team, and just like sweet and humble and kind. Like that's what I'll say. Like, just to start off, there's many lessons that you can learn from like working on the Geth team. The things that I learned were about like, what does maintenance of a project that is like an open source project that's used by so many, what does that actually look like? And I learned many lessons from the maintenance, like just watching this team maintain this code base and the certain problems that would come up that were like, I don't know, years worth of tech debt, and the way that they would address them, the way the like precision with which they would review certain PRs, and like how long it would take for certain things to move through. There's a lot of like unpleasant qualities about maintenance that would like make people kind of like want to pull their hair out. It's very like, you have to have a lot of patience. You have to have a lot of patience. You have to have a lot of focus, because many times like you'll review a PR and then you'll come back to it and you'll have to like regain all the context of what that PR was and review it again and in depth, and every new commit. And like there's many ways to make it easier to review like larger PRs, because a lot of times the PRs on Geth were very large. And actually, I think the second part of Marius's question was like, what lesson would you take back to the Geth team? Yeah, there's the problem is that they have so many external contributors, they can't like enforce certain rules on those external contributors in terms of like the way that they would make a PR. But I think that there could be if they, and maybe they already do, I don't know, but have some sort of like format for how they expect external contributors that are creating larger PRs that are like maybe more than like a couple files changed, like how they would approach creating that PR such that it makes it very easy to review and also very easy to re-review. Because it's not just, one thing to review, it's another thing to review that PR, ask for changes, and then you have to come back, regain that context, and then like continue reviewing. So if they were able to like find a nice way to like encourage external contributors to be able to conform to that kind of standard, then I think they would make their lives easier. But I don't know, maybe they already do this, or maybe they have some other format, because I've been kind of disconnected for the last 3 years from them. But I think that the main lessons that I learned were around like the patience that it takes to maintain a code base of that nature, and how slow and deliberate you have to be with the decisions that you make around it, because like it is really, really, really high risk in terms of like merging PRs that, may not be fully reviewed and tested, for example. And like the amount of testing work and the amount of benchmarking work that goes into making sure that every single release is like performant, doesn't contain any regressions, and is suitable for production use.
Yeah, we didn't even get into the testing part that much, but I would guess that the testing part of what you do with protocol engineering is like a whole other thing. Yeah, it's like a huge thing too. Okay, there's some more questions. We're not going to have time to get to them, but you can feel free to answer them. Oh, I just saw one. When full marathon? Are you a runner?
I do run, yeah. I don't know. We'll see when the full marathon. I don't know.
I'm kind of in the same boat as you. I'm a runner as well, but my rule of thumb is kind of like I'll sign up for any race that I don't have to like train extra for.
Yeah.
Because I just don't for me right now, I could probably do like a half marathon. Just wake up and go and do it, and not feel like too much pain after. Because I also could I do a marathon, like gun in my head today, if you were like, go run a marathon or else? Yes, I could do it and finish it. I just would probably be in pain, like a lot of pain after.
If I did a full marathon, I'd destroy my knees and like, but by like, I don't know, probably 35 kilometers, I'd be done.
Yeah, so I would just prefer not to do it that way. But that's kind of I just don't want to like invest more time to training extra for it because it's such a time commitment.
Like a full marathon is like an insane time suck. One of my like best friends just ran a marathon last year, and like having to watch how much time he had to sink into training for that was like insane.
Yeah. My dad runs marathons and he's like super upset. He's one of those. I mean, all marathon runners are kind of one of those, right? Like kind of obsessed, a little, a little neurotic.
Just weird.
But he actually ran the Berlin one last year or 2 years ago.
Oh, yeah.
And he said that was, he had a great time, I think.
Yeah, I did not have a good time running the Berlin half marathon.
Yeah, well, maybe you have a better time running the marathon, the Berlin marathon.
Yeah, maybe. I honestly probably just because of the sheer amount of people that were running the half marathon last year.
My dad said there were people just like peeing, like women like peeing, squatting on the street. I was one of them. Yeah. So like, what is that? Is that just like is because there's not enough toilets and people do it, or is that people like? But he was like, no one had like any shame about it. Like people were just doing it.
They just kept going.
You just
they would. You just do it, and like I'll be honest. Like I could not hold my pee. Like I just couldn't hold it while I was running because it was also like super hot. So I ended up overheating like on the day of the run because I'd never ran in that heat before. I didn't have any salt tablets. I had nothing with me. I like sweat a lot and I was also drinking a lot. So I diluted like the fluid in my body to the point where like I just lost all my salt. So I was just like, it was a mess. It was terrible. So like at the time I did not care.
Yeah.
And I also think that those women, wouldn't care either. I didn't care.
Yeah. Totally fair. I totally get that. Okay. I can't forget this. We asked every guest at the very end to give us a can you not. This is just like, you get it, right? Like, can you not do X, Y, and Z?
Oh my God, I have so many.
Let's hear them.
Okay, like how spicy or how bad?
The spicier, the better. Like level like 5 out of 5 spice is best.
Okay, so I have an issue with grifters. My 2 biggest issues I'd say are like issues with grifters and then like issues with like people complaining about how women have it really difficult in this industry. That's probably my spiciest one. I'm not saying like, oh, I had such an easy time and that means everybody else, must have had such an easy time. There are many women that experience like difficulties with their teams and like bad things that happen to them. But I would say like on the whole, there are many like great teams out there that like make an effort to treat women very well. My team, for example, is one of them. Like for a very long time, I was the only woman working at Celestia before, like also at Guess. Like the way that I've been treated throughout my entire career has been incredible. Like everybody has been unbelievably professional to me and has always given me actually the benefit of the doubt, which is something that I think really helps women get ahead in this space. And I think that if we spent like less time complaining about how hard it was and more time creating like good opportunities for women in the space, I think that maybe the perception would change. And I think that people complaining about how hard it is for women in the space actually reinforces the idea somehow that it's very hard for women in the space, makes it unapproachable, but that's not the case. Like for most places, I would say like for the majority.
Do you think you did anything different in your career than what you've observed, like maybe other women doing that helped you have such a positive experience?
I would say it helped that I was working with engineers. Like working with engineers is a totally different experience than working with anyone outside of that, because engineers, for the most part, like not every engineer, but like engineers for the most part operate like mostly like merit-based. And so they really don't see you as like a woman or like different most of the time. Like there's some that do sometimes, but like most of them will just be like, okay, there's this like person that's producing this output and like you're just a GitHub profile and they're just reviewing your PRs. And also when they interact with you, it's like totally like normal and fine. And they've always been like extra nice to me as well. And like just extra helpful. So maybe it's just my experience as like an engineer. I can imagine there's like terrible experiences on the other side of things where like things like if a workplace gets political, then of course it's going to get political and bad for everyone involved. And I think it can become extra difficult for women in those spaces. So I think maybe like on the technical side of things, it's nice and roses for the most part.
I actually have had the same experience. And like, granted, I haven't worked with nearly as many engineers as you have, but like the person that brought me into the space and like got me my first crypto job was like a co-founder, but like an engineer. And I like primarily reported to him for a while. Like, we're still friends to this day. And then like the last company I was also like ended up staying friends with a lot of the engineers somehow. So I do think there's something there. And I don't know, maybe it is just that engineers are more merit-based and less like have less biases with regards to gender and things like that. But yeah, I've had a similar experience now that you say that. I'm like, yeah, that's true. Engineers are cool people. Well, that was spicy, but I like it. I think let's just make more jobs for women and then focus more on getting those jobs, right? And that's what's going to drive us forward. Yeah.
Yeah.
Cool. Love it. Tell people where they can find you, Rene, on the interwebs if they want to follow you and keep up with what you're doing. Twitter,
Rene
what's
Lubov.
your handle?
Yeah. My name, Rene Lubov. Yeah.
Awesome. We'll include that in the show notes as well. Thank you so much for taking the time to join us today, for having Rehash be your very first podcast ever. Hopefully it was a good experience and a fun experience and not very stressful.
Yeah, good. Thanks for having me.
Yeah, thanks everybody for tuning in. We'll be back again next week with another episode of Rehash. Thank you for tuning in to this episode of Rehash. Rehash is hosted and produced by me, Diana Chen. Rehash is also supported by our community of NFT holders who curate our guest lineup each season. To get involved, head over to our website at rehashweb3.xyz and collect this episode as an NFT. Anyone who collects an episode becomes part of the Rehash community and will be able to nominate guests for future seasons. To learn more about how to become a guest on the podcast, go to rehashweb3.xyz/podcast. And to learn more about sponsoring the podcast, go to rehashweb3.xyz/sponsor. Finally, be sure to follow us on Twitter, Instagram, and TikTok at rehashweb3 or on Warpcast and Lens at Rehash. And join our community on Telegram at t.me/rehashweb3. If you enjoyed this episode, please rate, review, and subscribe on Apple Podcasts, Spotify, or wherever you get your podcasts. See you next week.